I'd like to invite the next speaker on stage, please. His name is Suraj. Suraj Nath. He's a senior software engineer at Grafana Labs. He was an early engineer at Clarisites. Clarisites streamlines reporting for sophisticated growth marketing teams. He's going to speak to us about building scalable OSS observability on AWS with Mimir, Loki, Tempo, and Pyroscope. Can we have a loud round of applause for Suraj, please?
It should be on.
Yeah. Hey, it works. Technology. Hello, everyone. I'm Suraj. I work at a company called Grafana Labs, and we make observability tools like Grafana. Okay. Observability tools like Grafana, Loki, Tempo, Pyroscope, and you learn about all of them in this talk. So I'll start this talk with the very programmer thingy, like hello world. Who here have written a program that looks something like this? You know, raise your hand if you have done it. You know, I mean, I expected all of you to raise your hands because pretty much everyone, or at least I, do, like whenever I try to learn a new language, this program like this or something similar is what I do. You know, like hello world. One thing that I'll say is what we did here was we created a log line. That log line just goes and prints hello world on our screen. So effectively, we learn programming by learning how to log things. So logging is the first thing that we do, right? Who here has, you know, debugged something like inserted print line statements when debugging things, you know, like, hey, yeah. Raise, all of you need to raise your hands, you know, like, because I did this week only, where I was trying to debug something, and then I was like, okay, I'll just throw a bunch of print line statements, run the thing, and then see and debug it, right? So even though I do have a debugger, this still remains one of the ways, you know, I debug things, you know, like I reached here, this thing got executed, right? That's again logging, right? So if we use an analogy, logging is like a hammer, you know. It's a very versatile tool, and you can use it to get things done. You can use it to build a house. You can use it to build a table. You can use it to build anything, right? But we should also not forget that there are many other tools in our toolbox, right? When you have a hammer in your hand, everything looks like a nail. Even the screw also looks like a nail. You can hammer it down, but you're better off using a screwdriver, right? And if you're building a house where you need to hammer thousands of nails, you're better off using a nail gun, right? So similar to that, let's talk about the tools in our observability toolbox. The basic four tools that we usually have are metrics, logs, traces, and profiles. Profiles, like we've been profiling things for a while, but continuous profiling is fairly new thing. You know, like who here has captured a profile? You know, like who here have hit like /p prof endpoint on Go programs, or taken like a profile dump? No. Okay. You guys need to profile more. You know. Anyway, and how Grafana's tool fit into the observability toolbox, right? So we have Mimir for metrics, we have Loki for logs, we have Tempo for traces, and Pyroscope for continuous profiling. All of these tools are open source. You can go on GitHub, look at the code, download it, run it, do whatever you want with it, right? And obviously Grafana, you know, because Grafana is the layer, UI layer that talks to all of them, gives you the nice dashboards, what you see. Because these guys sit in the background, do their work, and mostly they don't complain. You know, like you send some data, they'll store it. You use Grafana to pull them back. They'll happily return the data. So let's look at metrics first. You know, how do you use usually metrics, right? Metrics are mostly meant to, you know, like capture things, CPU uses, disk uses, how many requests I've sent from my service, how many errors have I returned to customers, things like that. And Grafana Mimir is our Prometheus compatible store for storing metrics. You can run it as a single binary, you can run it as like a microservice mode, however way you like, and it stores its data in S3, so it's cheap to run. And if you are already using Prometheus and hitting limits of Prometheus, you can just drop in Mimir, and then you'll be good. So let's see how Mimir works, right? So Mimir supports Prometheus format, open metrics format. You can also write influx or graphite data into Mimir via proxies that we have. So if you have, let's say, one application writing data to influx, two applications writing data to Prometheus, one more old application that is producing graphite metrics, you can still use Mimir and unify your data and then capture it and then query using Grafana and build alerts on top of it. So that was Mimir. Now we started with logs, and logs again is the first thing that you do when you set up your application. Even before you instrument your application for metrics, you capture logs, right? All the programs that you use that you have not created, all of them produce logs. Your web server, even your load balancer, your database. So you kind of get logs everywhere, right? And you need to pull them, collect them in a single place, and then find like, hey, what error did I see in this time range, or like show me this error message, how many times it has happened. So Loki is really good at that. Believe it or not, Loki is 5-year-old. Yeah, it turned 5 in this December only. So yeah. So Loki, what you do is you collect logs from all of your nodes. You can use Grafana agent or Promptail to collect them. You send it to Loki, and then you can use Grafana or log CLI. And you can also generate metrics from your logs using Loki. So you can say, okay, count the number of panics that I'm seeing in my application. Count the number of exceptions that I'm seeing. So it will run the query and give you the metrics instead of returning the logs. And if I say everything else is just fancy log. Metrics are also fancy log. Traces are also structured and fancy log. Profiles are stacked traces, but you can also represent them with logs if you are brave enough. But again, we're not talking about the hammer, right? We're talking about the nail gun and the screwdriver and the other tools that we have in our toolbox. But Loki is the powerhouse of Grafana Cloud logs as well. The same is true for all of our products, right? Grafana Cloud Metrics is powered by Mimir. Grafana Cloud logs are powered by Loki. So we use it at massive scale. To give you an idea, one of our cluster was pulling 1 terabyte a second from S3, and then we were told to slow down. So yeah, so Loki is that fast. And then I'll say why Loki is fast. So most traditional log storage systems, they would start with like indexing the whole log line. We looked at log lines and we saw like, can we make it cheaper? Can we make a trade-off here? So Loki by design decided to not index everything, and that is the reason why we can ingest so many logs, so much log volume without a lot of cost. So what Loki does is Loki will only index the timestamp and the labels that you tell it to index. It will not index your whole log line. Now it has a trade-off, right? If you want to search like one log line across your log that is not in your labels, then you have to search through a lot of data. So what we recommend is you filter down using your labels, and then you search for the log line that you're looking for. But sometimes even after filtering, you have a lot of data, right? I'll talk about, like what we are doing there. So Loki was announced in 2018, December 2018 at KubeCon. We released Loki 1.0 in 2019. Loki released LogQL, the query language v2 in 2020. And then in 2021, we worked on retention. We added WAL for reliability. We added out-of-order log support, because before that, you could only ingest logs in the order they were created. So if you ingested something, you cannot ingest like past logs. We removed that in 2021. 2022 was our year of scale. We did a lot of stuff. We added a new TSDB index. So before, Loki used to build their own index for the labels. And then we said, these labels are very similar to Prometheus labels. Prometheus already has a TSDB index. Why not just use that? So we basically used Prometheus's TSDB index as a library in the Loki, and then we built that. And then we got all the nice things that you have in Prometheus, and that added a lot of, like speed. And then we also worked on deletes, because all of us have accidentally logged some secrets, and then you need to go and delete them. It was not supported for 4 years. People were asking us every single day that, hey, I need to delete some data, I need to delete some data. So we eventually got around doing that. And then we did a lot of small changes, and all of them, ended up helping Loki scale. And right now, the Loki team is working on Loki 3.0. And Loki 3.0 will be even faster. And it will be faster for the use case that I specified, where Loki is not a great case, right? Where you're trying to search a needle in a haystack kind of query. The Loki team is working on, we don't really have a name for that feature yet. And I don't want to say the internal name, so I'll just say it's a feature that will speed up your Loki queries. So I asked AI, like, tell me how, Loki team looks like trying to work on Loki 3.0, and then it came up with this picture. And it's AI generated, because look at the fingers. So that's logs. So the third tool in our toolbox is traces. Right? I personally work on Grafana Tempo, our tracing product. So trace, again, as I said, it's fancy log, right? Structured. So what is a trace, right? Trace, if you think about it, it's nothing but a distributed call graph. Who here has like looked at a call graph or read about a call graph in computer science classes, right? Like where your function A calls function B, and then function B calls function C, and then it calls function D and E, right? Here, instead of functions, you have services, and each of your services will call other services. And as I said, trace is a collection of spans, and a span is a log line with some fancy metadata and start and end time. And then it also says who its parent is, and that's it. And that's how you build like a trace. And each service will generate a span for the things that it's doing, its operations, and then you push those into Tempo, and then Tempo will give you a nice trace out of that. So Tempo supports all the popular tracing format. So if you have your application instrumented with Jaeger and you're using Jaeger, you can just drop in Tempo and start sending, like point your collector to Tempo instead of Jaeger, and it will work. Same for Zipkin, OTel. OTel is recommended because we are building more stuff that works better if you're using OTel, and I'll get to that later. And again, Tempo will just take your data, will create blocks, We'll put those blocks in S3, and then when you ask for a trace back, we'll come and give you the trace back. So yeah. So one more thing that we have built in Tempo that I really like and that I feel like is the killer feature of Tempo is TraceQL. So raise your hand if you have used PromQL. I see some hands. Okay. Raise your hand if you have used LogQL. Loki's query language. I see some hands. Okay, I'll raise your hand if you have used TraceQL. As expected. So because TraceQL is fairly new, right? We released it. It's less than a year old. It's a tracing query language that is inspired from Prometheus' query language PromQL and Loki's query language LogQL. You see labels, right? And these are the labels that you attach to your spans. As I said, like span is a log line with fancy tags. So now you can query your traces or spans using these. And one more thing that we have done that is very unique to TraceQL is, because if you look at a trace is a tree, right? And we allow you to query that tree using TraceQL. So the first query up top you see is like resource.service is equal to A, and then the arrow operator, right? It's not greater than, it just means show me the spans where my service A, like the request, the span has service A and then service B. So it's something we call descendant operator. So you're saying, I need all the traces that went from service A to service B. You're trying to debug something. And the second query you see, right? You're saying, show me the traces that came from service A, had some errors, and then, like show me the service name. So let's say you are owner of for service A, you can execute this query and then you can see the names of services where you are getting errors from. Let's say you have a couple of downstream services. So TraceQL basically allows you to interrogate your tracing data that you have accumulated and get what you want from it. Technical difficulties. So this is another query, right? Here you are saying, show me all the spans where a request was received by my server and on the account endpoint. Because here, let's say you're debugging, somebody is reporting that you're getting errors on /account endpoint, and now you are saying, okay, show me the errors that I got from downstream services. So that was tracing. We are still building more features in TraceQL. I'm super excited about TraceQL and stuff that we're doing with it. We are hoping to, like see more people use it. And next time I give a talk, I'm hoping to see more hands raised up. So now let's go to profiles. Right? Profiles, again, as I said, is fairly new phenomena. And we have a product in this space. Our open source continuous profiling storage is called Grafana Pyroscope. And it was actually an acquisition. Grafana acquired a company called Pyroscope. And we had our own project called Flare. And then we merged them together to make an even better continuous profiling database. And we named it Pyroscope because Pyroscope is simply the better name than Flare. So I'll go touch upon profiling, like what is profiling. So profiling, when you capture a profile, what you do is you are looking at the call stack, and then you're saying, tell me what you're doing, tell me what you're doing, tell me what you're doing. You capture a couple of samples, and then you try to build which function was called for how long from that call stack, right? Most common profiling method is sampling profile because profiling has its overhead, and sampling profiler is what is the least overhead, most value method to profile things. And this is what a profile looks like. Like this is a stack trace. Some people call it a flame graph. Other people call it a icicle graph because it looks like icicles are falling. If you flip it around, it's like flames are coming up. So that's why the name flame graph and icicle graph. And what you see from that end to this end is the resource uses. The longer the line, the more resource. So if it was a memory profile, it would be more memory uses. That okay, this function is using more memory. And down is what you see the call graph, right? Which function is calling which functions. So you see the nested lines. This shows a better example. Here you see there is a method called parse matchers. So anything above that was the functions that led to this function, and anything below this is what the functions that parse matchers is actually ended up calling. So, and then continuous profiling, it's you do this continuously and you have continuous profiling. So why continuously, right? Like you say, okay, profiling has some overhead. Why do I need to continuously profile? Continuous profiling is really helpful because you don't know like when you'll need that profile, right? So let's say an incident happened. I'm in an incident, right? I'm trying to debug why my errors spiked up or CPU spiked up, right? The CPU spiked up 15 minutes ago. I cannot time travel back and capture a profile, right? So you capture and then you store it in a database, so then you can query. Because time traveling is not possible, but capturing profiles is possible. So yeah. So one thing that you can do with that is you can also use these profiles that you continuously captured and plot the resource uses that you have captured, right? So again, you end up generating some metrics. So what you see, the bottom panel is the continuous resource uses that you have observed from your continuous profile. And here what you see is what we call like the top table. So it's just another way to look at that graph, the stack trace or flame graph, where it shows the method that is spending most time or most CPU or most memory. You can put it like that. And then, yeah. Again, it being a Grafana product, it works really well with Grafana, obviously. And other of our products like Tempo, Loki, Mimir. Again, it's very cloud native. You can just deploy it anywhere. It does service discovery and all the stuff that you expect a cloud native piece of software to do. Right now, it supports 4 languages. So Go, because pprof, right? That is the first thing that we added support for. Then Java. We worked on a project called jpprof. I think I'm not really good with the name, but something like that, where we added pprof support in Pyroscope, so you can capture pprof style profiling. And we're also active in OTel's profiling seg to help contribute and form the OTel profiling standard when it comes. And then we also have support for Python and Rust. So you can capture your profiles if your programs are written in these languages. And Flare is available on, it still says Flare, right? Because obviously, but it's Pyroscope now. But if you go to that URL, it will redirect you to Pyroscope. So you can hang out in our community Slack, look at Pyroscope channel, and talk to the actual developers who build it. So now coming back to it, right? These tools on their own, they're cool, but what would be even better if we connect them together, where one tool can talk to other one, or you can jump from metrics to traces and then traces to logs, vice versa. Or what if you're looking at a trace and then you can see, okay, my service is taking a lot of time, let me look at a profile. So that would be even better. So we just did that, right? So here you see, in the same dashboard, you see metrics, and along with metrics, you see some logs and then profiles. You adjust your time range, and then your panels will automatically adjust, right? And one more thing that we'll see is here you are seeing metrics and then profiles. Then from profiles, you're jumping to traces. So this side, you have a trace open. And another thing, if you see the same profile is just embedded inside a trace. So now you don't even have to do a query. You can just expand it, and then you'll get a profile inside your trace. So this is just a bigger picture of the same thing. So classic trace, and then you said, okay, this find near vehicles is taking a lot of time. Let me look at a profile. So Grafana can just do this. Another one is, let's say you want to jump from your metrics to traces. There is something called exemplars. So when you capture your metrics, you can also generate exemplars. So exemplars are extra metadata that you push to Mimir or any other Prometheus compatible storage that accepts exemplars. And then you can put stuff like, okay, this was the trace ID, this was, like anything else that you will not put in the labels. You can put it in your exemplars. And then you can jump from your metrics to traces just by clicking the button. Now, going from logs to traces, right? Grafana has a feature where if you log your trace IDs in the log lines, you can turn the trace ID into a button that you can click, and then it will directly take you to the trace. So it looks something like this. So when you configure your logging data source and you are logging your trace ID, you can tell Grafana that, okay, this is the label that I'm using for my trace ID, and this is what it looks like, and link it to Tempo. So then you'll get a button, the button that you see. And if you click that, you will jump into a trace. Now, going back from traces to logs, right? You can also configure Tempo data source to take your logs and then jump from traces to logs. So that was the toolkit: metrics, logs, traces, and profiles. I don't have the time to show you the full demo. That's why I created a QR code. We have a repository called Intro to MLTP. You can just git clone this repo, cd, and do Docker compose up, and then open Grafana. So Grafana runs at 3000, so you can just open localhost 3000, and you'll get a full metrics, logs, traces demo, and then the correlations and everything. It has a bunch of services in it that you see. It should look something like that when you do it. Scan the QR code if you want a link to the repo. And this is what it should look like. If it was a live demo, I would have showed you, but we have images, so we'll have to do with that. So yeah. And Grafana and AWS, right? This is an AWS event, AWS Community Day. All of here are using AWS in some capacity. So talk about how Grafana and AWS are, like you can use Grafana to monitor AWS, right? So in Grafana Cloud, we have a solution called all-in-one AWS experience, where you can connect your CloudWatch metrics, CloudWatch logs, and Grafana will pull those, store them as Prometheus metrics and logs in Loki, and then you get all the goodness of Prometheus and Loki on your CloudWatch metrics. And it, by default, it monitors most services, I think 50 plus services. You can scan that and find out more. Another thing is, if you are trying to buy, let's say, Grafana Cloud at a big company where you have to go through procurement, legal, and vendor onboarding and all that, you can just buy Grafana Cloud on Marketplace, AWS Marketplace, and then you get to skip all that. So you can just use the product without going through all the onboarding side of things, and then you will get a single bill. So Grafana will be billed by AWS. And if you have AWS credits, I think you can pay with AWS credits also. So for startups, that's also nice. Another one is obviously the OG CloudWatch plugin. Grafana has a plugin to query CloudWatch, fairly standard. You can write your CloudWatch queries in Grafana and get that data. And that's all, folks. A little bit over time, but I think that's, yeah.
Thank you so much, Suraj.